This tutorial continues our work with linear regressions in the lesson called Like a Glove, and it's activity 2, which is about using data and using regression lines to make predictions. So in this assignment, we're going to use the data that's right here in this table to make predictions about global temperatures. So in this table, we have 4-year spans. So span 1 is from 1957 to 1961. Span 2 is from 1962 to 1966, on and on to span 12, which covers the time period from 2012 to 2016. And then for each of the 4-year spans, here's the average temperature in degrees Fahrenheit. Now keep in mind, sometimes between 2 spans, the temperature goes down. So if you look at from span 1 to span 2, the temperature goes down a little bit. And if you look at span 2 to span 3, that temperature goes up a little bit. So for this first question, you're asked to identify the range of the data set, and the range is the highest value minus the lowest value. So to calculate that, you'll need to find the highest value in the data set, which I see 57, I see 58. If you look at these 458 values, this one is the highest, span 12. And then the lowest, don't be fooled, it's not this one, because span 2 has a lower temperature than span 1. So for the range, you'll be taking this number minus this number, and then you'll have your range. The independent and dependent quantities and their units of measure, remember that the independent quantity is the one that you have on your x-axis, the horizontal axis. In this case, the span is what we're going to have on our x-axis. So that's our independent quantity. And the temperature, the average temperature for that 4-year period is going to be our dependent quantity. So time is often the independent variable, and in this case it is the span number, and our temperature is our dependent quantity. This span is measured in the units of years, 4-year spans, and this quantity, our dependent quantity of temperature is measured in degrees Fahrenheit. So that's number 2. And when you graph this, the question is it a function, and decide why or why not. For this one, think about what you know about what functions look like. In particular, think about the vertical line test. So first, go ahead and graph your data. You'll need that on the next page anyway. And then look at your data and see if it passes the vertical line test or not. So to graph this data, go to desmos.com/calculator. And then what you're going to do is you're going to click on the plus and then choose table. When you do that, you'll be able to enter the span number and the temperature in Fahrenheit as a coordinate pair. So if you look over here, you have the point 1, 57.250. You have the point 2, 57.121. You have these coordinate pairs. And when they get graphed on the coordinate plane, you'll see they're right here. Now, you'll want to use your mouse and zoom in so that you can see the relationship better. So use your mouse to zoom in, and then you'll be able to see the data better. So this point here is 0.157.25, that's 1. And then the Y value is 57 and 25 hundredths. This is the point for span 2. 57.121 is 57 and 121 thousandths. So you have all your points for span 1, span 2, span 3, all the way up to 12. And so here's the data. You'll need to put this graph on the next page by hand. And now you're able to answer that question better about, is this a function? So look at this data and ask yourself, does this graph pass the vertical line test? And then explain why or why not it's a function. So then if you're going down here, now that you've used technology to make the scatter plot, showing the relationship between the time spans and the temperature, what association do you notice? Is there no association between time and temperature? Or is there a negative association? Or is there a positive association? So think about if the data looks random, if it looks like it's going downhill, or if it looks like it's going uphill. So that's how you decide on number 4. And then the last one is the last question here, between which consecutive spans was there a decrease in global temperature? So for that question, you can either look at the table or you can look at this graph. And you ask yourself, when does the temperature go down between years? So for example, if you look at between span 1 and span 2, does the temperature go up or down? And you can also ask that question if you're looking at the table. Between span 1 and span 2, is the temperature going up or is the temperature going down? And for number 5, there are 4 correct answers, so list all 4. Between what time spans was there a decrease in average global temperature? That is, during which spans does the temperature go down?